Hi, I'm Lauren Brown. I'm here with Andrew, and we're going to go into the details of the creation of our practice robot.
So we built our robot on a 6-wheel tank drive. Each side has 2 motors in order to power the tank drive, with a total of 4 motors on the drivetrain. And then our other 2 sim motors are used to power our lift mechanism. So this is our design for our lift mechanism. There will be a chain that attaches on the side of this car and runs all the way down to the bottom in order to be able to run both of these up and down in order to pick up the totes. So then these are gripping arms, and they're powered by pneumatics in order to open and close. When the pneumatics are pushed out, they're in the open position in order to clear the tote, and then they go down and then close onto the tote. We also have our rolling mechanism here, which will be that the robot can back straight up against the where the chute door is, in order to have the totes slide straight out of the chute into our robot, so we can control where they land inside of our robot. Rather than having them end up tilted, we'll have them straight on, so it'll be easier for the robot to pick them up. We're going to pre-program a lot of our teleop stuff, so you can push buttons in order for these to go up to a specific height and back straight up and do any of those routine tasks. And then all we have to do in order to score is we'll have a container with a pool noodle in it to start off with, and then we'll back up into the wall and make a stack of 6 with the container with the pool noodle for a total of 42 points. And then all we have to do is drive straight and set it down onto the scoring platform. Our goal is to be able to do that 2 or 3 times per match. And then we also have these designed to go high enough in order to put 3 totes on top of 3 of the yellow totes on top of 1 tote that's already on the step, in order to score a 4 stack during qualification matches for the cooperation mission. So this is our prototype robot, which we riveted in order to figure out exactly how everything will work. And we've already figured out some things that we have to change on our final robot. So this is our final robot. That's welded and will be powder coated black and red for Minotaur. And so we'll just have to put that all together, and then we'll be done.
Hi, I'm Lauren Brown. This is Leaf to Bench Strip.
Hello.
And we're here with the FRC robot, Go Minotaur, Team 1369. I'm here with the FRC safety captain. Could you tell us a little bit about what it means to be safety captain?
To be safety captain is to mean that I enforce that this is a safe and friendly environment for learning about engineering, programming, and gracious professionalism, because injuries, they will hurt you, they will hurt me, they will hurt the team, and they also will cause harm to the world.
Absolutely. What kind of things do you enforce as safety captain?
Well, often I have to enforce the wearing of safety glasses and closed-toed shoes. Those are the most common violations. When working with special tools, we often enforce the use of gloves and hearing protection.
Awesome. I see that a lot of the girls have their hair tied back. Is that also a safety
Yes,
measure?
it is. Mainly because when you have long hair, it can get caught in the machinery you're working with, and that can cause unwanted injuries, so we make them tie it back in order to prevent it.
Absolutely. And you enforce this on and off the field, such as at practice and at tournament?
Yes, of course. You can get injured anywhere. I mean, like, I could get injured when walking around. Just because you're not in a tournament doesn't mean you won't get hurt. We have to make sure this is a safe environment, because injuries, they are not good.
Absolutely. Well, thank you very much for your
welcome.
time. Hi, I'm Lauren Brown. I'm here with Mr. Jones. He's a mentor of the FRC robotics team, Team 1369. Mr. Jones, what exactly are you teaching us here?
Actually, I'm overlooking the project that they're doing and making sure that when they assemble and things, they assemble it in the right way. Also, I help some of the kids, operate some of the tools or show them how to operate it so that they can do the work that they need to do. And in the beginning, I'm just there as a support person, you know, make sure that there's somebody with some knowledge behind them to help with the mechanical end of it, you know. The kids actually do the work. We just look over the shoulder, make sure they're doing things in the proper stage.
Awesome. What influenced you to become a mentor to the FRC team?
I'm actually Nicholas's grandfather.
Oh, really?
Yeah.
That is awesome.
Yeah, I'm married to Richard's mother.
Awesome. Do you have a background in electronics or?
Actually, I spent 45 years as a welder,
Really?
a mechanical welder. So I built, worked on nuclear power plants. I worked in maintenance. I worked on ships. I built reactors for the Navy, for submarines. You know, so pretty well a vast experience.
That is amazing. That is amazing, and it's awesome that you're being able to pass down that knowledge to not only your grandchild but the team as well. That is amazing. Thank you so much, sir.
All right.
Hi, I'm Lauren Brown. I'm here with Jonathan. Jonathan, can you please explain a little bit about what you're doing?
Okay, so this is part of our chain breaker, and so that it can break chain more effectively, we need to grind down this part so that it fits within the roller of our roller chain.
Awesome. And we're using a metal grinder?
Yes.
Awesome. Can you show us how this works?
Okay, so I had this clamped down on some vice grips, and I put it up against the grinding wheel, and I turn it as I grind so that
It gets that smooth finish?
yeah, so that it's not ground flat, it's round.
Absolutely. And what did you say this part was for again?
This part was for our chain breaker.
Chain breaker. Awesome. Well, thank you very much. Good job. Hi, I'm Lauren Brown. I'm here with Andrew. Andrew, can you tell me a little bit about what you're working on?
So I'm currently riveting these bottom sprocket brackets on in order to attach our chain up there, which allows this to roll. And it's powered by the motors back here.
This is the outlet that I told you. Awesome. And what is this you're using?
This is an air hydraulic riveter that uses air pressure and hydraulic fluid to rivet the material.
Could you explain what riveting is?
Basically, it pulls this bar back and then cuts it off, so this is pressed flat inside of what you're riveting, and it stays in place.
Awesome. Thank you very much.
Yeah, try one.
Hi, I'm Lauren Brown. I'm here with Erin and Janice, and we are cutting something. Can you guys explain what this is?
This is a chain mount piece. Basically, it's attached to our lift assembly, and what it does is it holds the chain onto the lift assembly so that the chain can lift the whole assembly.
And why are we cutting it?
Because it's too long.
Yeah, it's too long. We figured it out.
Yeah, it's too long. So we're cutting it.
Awesome. And we're using, what are these tools?
These are hacksaws.
Awesome. So you want me to give you a hand here?
No, it's fine. It's fine. You sure? I got this. I got this, Lauren.
Absolutely.
I got this. I got this.
So I see you guys just saw back and forth with the hacksaw.
Yeah.
Yeah.
Awesome. Thank you guys very much.
Thank you.
Hi, I'm Lauren Brown. I'm here with Michael Schutte. Schutte, can you explain to us what this part is for the robot?
Oh yeah, this is the lower chassis, the drivetrain as it's called, and basically what it does is it just allows the robot to move around.
Awesome. Can you explain to us how these wheels work? What are these?
Well, this is a tank drive setup that we have right here, and how it works is we have these motors on either side of the robot. It's connected to a assembly box, which allows it to have more torque and more speed. And then we have sprockets here, which can then connect to the sprockets with chain. and which that allows all these wheels to move. And since they're individual, they can either move forward or backward with each other or against each other. So you can have like a 0-point turn, say.
Awesome. That's really awesome. Thank you. Lauren Brown, and I'm here with Erin. Erin, can you please explain to me what this is?
This is our lift mechanism for the robot so that it can lift and stack it.
What exactly does it do? How did you go about making it?
Well, what it does is this is the pneumatic cylinder right here, and when it opens like this, the drivers go like this, and when this closes, it closes it in on the Tote. And the reason why we have it like that is so that there's a hard stop, and it's going to be like this most of the time, so we have to use the left air to do it. And we designed it all on Autodesk Inventory, which is a CAD program.
That's awesome. So these up and down?
Yeah.
So they're able to stack the Tote. That's awesome.
This chain right here is actually going to attach somewhere down here. This is right here.
Oh, you ready to eat good?
Thank you.
Hi, I'm here with Andrew. Andrew, can
No,
you explain what we're doing?
open the door for what?
So we're using this chain breaking tool to take off part of
There's
the
Gojo up there.
one link of the chain, so
There's
we
a
can
hose on the
attach
side
it
of the wall.
around here like this.
Would your mother let me wash my greasy hands in your sink?
You want me to hold that for
I
you?
didn't think so.
My mother would.
Yeah, okay.
Hi, I'm Lauren Brown. I'm here with Tristan. Tristan, can you tell me a little bit about what you're working on?
So this is our chain drive system to lift up these carrier cars for our totes. And what it is all of this is connected, and especially another chain right here that lifts this up.
That's great. Now it looks like these are all connected. Can you explain how you get these on and off if there doesn't appear to be an opening?
So what we do is first we measure the chain, and then once you get that measured, we break it. We use an extractor tool to pull out the pins, and then we put the size chain on there, and we use the chain puller to put it together, and use a master link to put the master link in the holes, and we put them together.
Awesome. What size is this?
This is a size 35 chain, which is all uniform throughout the entire robot.
Awesome. And moving down the robot to here, I see this is the motor.
Yeah, this is the sim motor. The sim motor drives all the chain throughout the entire system.
So could you demonstrate how this would work?
Not the best night.
Quite safe.
Oh yeah.
Once you move the chain, it'll pull this. This is moving down right now. You have the chain like this, it's moving down. So yeah, the car will be moving down.
That's going to be cut off right there.
That's awesome. I also see that farther down here in the robot, we have this tank drive.
Bring this to the screen.
Is this the same chain you said?
Yeah, this is all the size 35 chain. All this chain is connected to these two sim motors on here in this gearbox, and all the wheels are chained together to the same gearbox.
Cut it off right
all
there.
moved together.
Awesome. How would this chain,
Right there. That'll hold that piece in.
to here,
Unless you want to cut off above it and roll it
The other
over.
piece right here that connects to the chain over here.
Cut it off up
oh, I
here.
see.
Yeah,
So
That
that
might
it
be a
just,
good
an
idea.
inch above that.
Yeah.
I think that's probably your
Yeah, let's
best.
bend
thank you very much.
And then bend that over. You
Pleasure
want to
talking.
keep bending?
Hi, I'm Lauren Brown. I'm here with Isaac and Tristan. Isaac, what are you doing here? Can you explain how you're going to do stuff?
I need to connect the two chains together and then get a master link that is going to tie the chain so that it will stay together.
Awesome. And this is for what? This is for the tank drive? This is the chain link for the tank drive? Is this the real robot or is this the practice one?
This is
No, it's Tristan. No, it's the girl.
This is the
Yeah,
real
last
one.
year I was with the chain man and Tristan came along.
Absolutely.
Okay, so when
So
we
how
put
this
the
is going to
competition
work,
together,
if I'm correct,
that chain
is these are going to turn and this is going to turn and this is attached to these spin motors, right?
correct.
Yeah, and so this is going to, that's going to be what it's going to turn these. And I guess we have little tags here saying what they're for. This is for the left front, this is the right front. And so we get to know how these are going to work. Being able to turn these robots and maneuver correctly is a key component to scoring points in this challenge. Thank you very much, guys.
You got it folded over. Keep it flat.
Hi, I'm Lauren Brown. I'm here with Nathan, our electronics specialist, and Daniel, our programmer. Daniel, could you tell me a little bit about what programming is?
Alright, so programming is basically where I'm telling the robot what to do. The mechanical people, they're building the robot, right? But programming, what we're doing is telling how it's going to operate. For instance, I might say, if I push this joystick forwards, I want the robot to move forward. So if I press this button, I want the robot to pick up a tote, right? So I'm basically like giving the instructions to the robot about what to do.
So it's like a body and a brain scenario, with the brain being the program.
Yeah, exactly.
Absolutely. What kind of program are we using here?
So the programming language that we're using is C++. It's a text-based language, which means I type in all the commands. I'll type in what I want to do.
Could you give an example?
For, like what I was saying about the driving, I might type in get Y direction on joystick, and that'll say, alright, whatever the value of this is, however far I'm pushing forward, get that value, and then I can set it to the motor.
Absolutely. How many lines of code are necessary, do you think, for programming? What do you use?
I mean, it's gonna change depending on your, like, how in-depth your program is, how much you've written. Right now, we're sitting at just under 3,000 lines of code.
Under 3,000 lines of code, wow. What kind of things are you going to be programming on a robot?
So the primary things are the drive thing, right? So that's just forward, backwards, left, right, turning, all that stuff. And then the lift part, which is so bring up and down the totes to grab the totes and store those points, basically.
Awesome. Well, thank you so much.
Thank you.
Hi, I'm Lauren Brown. I'm back with Nathan, our electronics specialist, and he's going to explain to us a little bit about the electronics of our robot. So, can you explain to me what this is? What do you call this?
So, this is our electronics board, where we house all of our electrical computer motory things.
Yeah, but if we were attaching to the
these
chain
are
up here.
sim motors, you said?
Yes, these are
And you want to bring down to
sim
here.
motors
We're attaching up
from
here.
Andy Mark.
We're not attaching down here anymore.
What are
Attaching up
these?
here.
Okay.
These
Yeah,
are
because you're
across-the-road electronics Talon SRs.
What do they do?
These are motor controllers that interpret the commands from the Stereo, or the Robo Rio. We don't use the Stereo anymore, so we don't like to talk about that.
They're not going to be paid.
And they make the motors go.
So those are up here too. That's
Yes.
why, because of the sim motors.
Okay, so none of this
So what is
gets painted?
this?
None of this gets painted.
That's our voltage regulator. It makes sure we have 12 volts where we
That's
need it.
okay.
That way our motors
So
don't
these
just
brackets
die
we want
with the
painted?
battery.
And these
And these are not milled out.
That is our power distribution board with our circuit breakers. These are 40 amps and these are 30 amps.
What do the circuit breakers do?
The circuit breakers make sure any motor or motor controller doesn't draw more amps than it's supposed to.
Why would that be a safety hazard?
All right, so
It would both be a safety hazard and an expense, because if it draws too much current, then the motor breaks and everyone
you probably do that
dies.
right now. Do you have your file?
Absolutely. And what is this piece right here?
That is our brand new 2015 Robo Rio.
That's asking him to. You're
And
asking
awesome.
Nick to
And
do
what
some
does
work?
that piece do?
This is the brain of our robot.
So you're saying, I saw you over there with our programmer earlier making that piece of program, and you're saying you would send it to this?
Yes, this is where all of our code goes. It gets compiled and downloaded to here, and it gets run.
These brackets
from
here
there.
need to be milled
Awesome.
first. Okay,
Well,
that's
thank
first
you
to
very
mill.
much.
No problem. Then these pieces that are not.
Hi, we're going to take a moment and listen to them talk about working out the kinks and perfecting the robot as much as we can do tonight.
The bottom of the bottom tote needs to be right there, 30 inches. That's the bare minimum. So add an inch, so you need to be right there. Okay, 31 inches.
I don't think you're going to be able to do that.
So 31 inches, and you need another 10.
Unless unless you move that sprocket on the competition lap.
Hold that up.
We could mill off that a little bit, and then move the sprocket.
No, because we'd have to get this bottom bracket to there. To 41. We need 30 inches to get on top of 2 totes on the step.
I don't think that's that important.
No. I don't think so either. It's just something we just can't do.
Yeah.
We can't go up.
Alright. Hi, I'm Lauren Brown. I'm back with Leaf, our safety captain. He's going to explain to us how this rolling mechanism was made.
Well, first of all, we cut 4 pieces of PVC pipe at identical lengths, and we took these steel rods and placed them through these holes here at 3 hole increments. And then we put the PVC pipe on those axles. This is used to reduce friction as the tote, when inserted through the chute door, down this into the robot's arms.
Can you tell us a little bit about how they cut these pipes?
Well, you have to use PVC cutter in order to cut these, and you had to measure these at nearly identical lengths so that you have even amount of distribution. And as you can see, if you look at 3 hole increments, you have an axle for every hole. These aluminum axles. So
Are these aluminum or these steel?
Those are aluminum. These are steel.
Hi, I'm Lauren Brown. I'm here with Isaac. Isaac, can you explain to me what this does?
Well, in the human player portion of the match, people have to put the totes through the chute door, and the tote is going to go through here on this little conveyor belt thing and go into the lip.
Awesome. So they're going to insert the tote here, just to be clear. Insert the tote here, and they're going to roll down these PVC pipes.
Yes.
And then into this, which is the lifting mechanism. And then what? Do you know what happens after that?
We're going to stack with the
Awesome. Thank you very much.
I'm gonna put this on the robot.
Hi, I'm Lauren Brown. I'm here with Andrew. We're going to demonstrate how this tote is going to go through our robot.
During the teleop portion of the match, in order to make a 6 stack of totes and bring them over to the storing area.
Absolutely. So first, the human player is going to insert our tote here in the robot, and it's going to go down.
And then the robot will drive forward in order to push the tote a little bit further back into the robot. Then the pneumatics will actuate and push and grab onto the tote, and then slide out in order to pick up the tote. Except the pneumatics are much stronger than we are.
Thank you, Andrew. Hi, I'm Lauren Brown. This is Jonathan. We're on Minotaur Robotics 1369 FRC. Jonathan, can you tell us what we're working on here?
This is an aluminum plate that's going to be mounted on the back of our competition robot. So what do you want to know about it?
First, let's ask, what is it made from? How did we create this?
Okay, so here's how we made it. We first started out with a 4-foot by 8-foot sheet of aluminum plate. It's 1/8 inch thick, and we cut it to this size. And then afterwards, we put this in our plasma cutter, and with the CAD program, we cut out this design. We cut out our logo, our team number, or our team name, rather, our team number, a hole for our safety light, and 2 holes for pneumatic tubes.
What else went into it? What else did you do after we plasma cut it?
So after we plasma cut it, we started falling off the edges, and I was polishing the surface. And after it's done being polished, we're going to take it to a powder coat, and we're going to powder coat this piece black.
Well, thank you very much. Thank you.
So basically, or 20, 27 and 7. So basically from the bottom to the top, it goes out an 8. Or a little bit more than an 8.
I feel like we could have cut a lot more.